So in this slide, we address myopia and hypermetropia, and then going to the next challenge, that is astigmatism challenge. This is a quite difficult one because it's not just about the focal length, but we need to change the type of glass, that is cylindrical lenses. So we make a small micro grooves on the surface of the lens that will be placed after the gel, and then if we have just the ease of production, just the vertical lines, we can just rotate it by 90 degrees to have the horizontal as well. So we can just have that. This is actually targeting the customers who has the horizontal vision correction and the vertical vision correction. So in case if a patient has both, then what we can do is just put them on top, and then we have both the array of columns and grooves. So it can be used for both horizontal cylindrical lenses and also as vertical cylindrical lenses. And then you fill the material inside, so the material itself acts as a refractive index like cylindrical lenses, so it can be addressed. And then comes the calibration device, the main part, which should be used to change the focal length. The main idea in this is that this can be either placed in one particular designated location in a town or a place or supermarket like that, or given to customer directly to get his own calibration done. So the way it works is that you just put the lens in, and then it is an enclosed black box, just the size, and then you heat it, the material will soften, and then you pull it with a mechanism, with vacuum suction or alignment things, and then it will be deformed, and then you expose it to the UV light, so it hardens again, and then you have the product ready again. So it is recalibrated to a new power and a new focal length, so the person can just fit it into his glasses and start using the same glasses. So this is just a 70 degrees Celsius. The reason why I kept this is when we are talking about sustainability and the concept of recycling. So consider if you throw this glass away, then for recycling you need to melt it, or if you are using a fibers, you need to remelt it. So that consumes a lot of energy. But when you just have to increase the temperature to 70 degrees Celsius and use it inside this, it's very easy. It is sustainable. And then this is the additional thing that we could do with the lens. As said before in the previous slide, here we have a gap. We can create one and put it with around 500 nanometer coating, which gives you a tint on your lens. So some people ask, you need sunglasses as well as this one. Yes, right. So you can have this one particular layer for the custom-made product, and then change the color of it depending on the type of UV wavelengths that you hit it during the calibration. So consider you want a yellow color, then hit it with a particular UV that with the calibration. Just calibrate, change the colors, use it again. So that's the plan. And then what I claim from this product is that you save a lot of money over time. Consider as an average 100 euros you spend every year to buy a new glass. Instead of that, just spend 120 euros to buy this variable glass, and recalibration costs will be very less. So that over time of 3 years, instead of 300 euros, you just spend around 160 euros to have savings, and also the time. So once you get the prescription, you go to a shop and say, I want a new glass, but the shop says, 2 days please, you'll get your glasses. So in the recalibration part, you just have to spend an hour or so, depending on the polymer materials that you choose, and then you save the time there. And the style and the customization that you can do, have the box calibrated and just choose what colors you want, depending on the basic. And you can also amend it with respect to the primary colors change. And the last one is, we address the climate change by just recalibrate, reuse, recycle. And I have some reference materials which shows you exactly which components to be used and it seems very promising because we are using biodegradable polymers, not just the polyvinyl stuff. The photopolymer resins that is bio-based, so it really contributes to sustainability. And thank you. The last